Let's go to our topic today is how to enhance OpenStack infrastructure performance with machine learning and algorithms.
Okay.
I have to push the button.
Data is everywhere in today's world. In today's world, the data is everywhere. So it's the field that drives innovation and progress. And OpenStack, our context today, is no exception. So
We're going to discuss today our view on efficient cloud resource management. What are the challenges and opportunities in building modern monitoring systems, and how we can use data science, machine learning in OpenStack context to get more efficient and reliable services. Sorry.
Yeah. Okay. So, what can we actually do with the data within the OpenStack realm? Firstly, we focus on collecting data. Within the OpenStack environment, it means gathering the information about usage patterns, resources allocations, and system performance. It's basically a very crucial phase since it creates the foundation for the next step.
And next we move to data analysis and interpretation. Here we analyze patterns and interpret what they mean for our OpenStack deployment. It helps us understand strengths and weaknesses of our deployment.
Okay, so now why bother with data at all? So here are some advantages of its utilization. The first thing is it empowers us to make informed decisions. So basically, having a good understanding of our infrastructure empowers us to make strategic choices that lead to better outcomes. Secondly, it gives us a competitive edge. By leveraging data, we can optimize our OpenStack platform, outperforming others in reliability and.
Utilizing data leads to improved customer experience. If our services work smoothly, a customer benefits from more reliable services. And moreover, it helps with cost reduction.
Okay, and let's not forget about risk mitigation. When we understand use data patterns well, we are able to anticipate issues before they become major problems. So, thus reducing risks and enhancing the performance. Okay, but how does it all align with Sardina Systems? So, in order to address this question, we'd like to talk about common approaches to workload distribution.
There are two fundamentally different ways to resource utilization. The first one is about distributing all load for all available resources. And the second one means compactly load all load to some part of available resources.
Okay, now let's take a closer look to those approaches. The uniform workload distribution allows the system to easily cope with peak loads, but the typical state of the system is that the load on each hypervisor is usually far less than its capabilities. Resources misutilization leads to operational cost overruns, and basically this is the main disadvantage of this approach. As well, it's usually coupled with higher communication overhead and management complexities.
Talking about dense workload distribution, higher load on one hypervisor means higher risk in case of its failure. And if heavily loaded hypervisor experiences an issue, it can potentially disrupt a larger portion of systems workload. So, and it can leads to more. It can have more impact on service availabilities.
Well, on the positive side, sorry. On the positive side, we can say that dense distribution usually results in more efficient resources utilization, and it also supports more. Well, it supports dynamic workloads allocation strategy. So basically, it distributes the workload in the places where it can fit in the best.
The choice between these approaches depends on specific requirements and characteristic of your workload in an OpenStack environment. So, and we have to say that the first approach is implemented in standard OpenStack filter scheduler, and the second one in Fishow's workload manager.
Okay, so computing cluster is rarely used at 100%. So it's where the Fishow's workload manager comes into play. Basically, the key components of it are placement and rebalancing engines and power manager. So the first thing, the placement engine, actually it finds the optimal place optimal place for a newly created VM, taking into account the data on the infrastructure status and historical data. And basically, sometimes it's a pretty difficult task to be solved, since we don't always know how much resources will this virtual machine require. So we can estimate it from the data, and also this slightly makes the life of our next component a little easier. So
the main purpose of next component is rebalancing engine is to maintain the infrastructure in optimal state. This component uses data not only to find the optimal solution for the load distribution, but to predict whether virtual machine will migrate successfully. So this component monitors resource usage and make live migrations if necessary. And, it's a core component of whole workload manager. It's like, yeah.
okay, and now we come to our power manager. So basically, it's meant for keeping power consumption of our system as low as possible. Basically, what does it do? Well, to start off, we set the benchmarks for power that are being run on start of hypervisors. It's like having a standard for how much power it should be using. And next, it uses information about active and inactive hosts in order to be able to make some decisions.
It catches possible appearance of idle or recently loaded hosts in order to decide whether any host should be enabled or disabled, taking into account the power efficiency of that host.
Mm-hmm. Next slide, I guess.
Oh, sorry.
Okay, let's go to numbers. Well, on the average, computing cloud resources utilization is usually varies from 10 to 35%. Why does it matter? Actually, following the above mentioned dense distribution workload approach, it can be raised to 60, 70, or whatever percents. So actually, our FishOS rebalancing engine actually just frees the hosts from workload, and it's where the moment where our power manager comes into play.
Mm-hmm. Power manager just turn off the unused hypervisor, and it's like basically turning off lights in a room that you are not using, and just saves energy and money, and that's how cloud consumes less power, and this reducing operational expenses and impact on the environment.
Okay. I think we can get to the next part of our talk, is monitoring of the infrastructure. So basically, what are the challenges and opportunities in monitoring the complex systems? Actually, big complex systems generate a huge amount of data, and some of those data are crucial, some of those are not. Some data doesn't require immediate attention. So the key challenge is how to decide which information is worth showing to the operator and which is not. So basically, and here are some approaches that can help us. Those are logs classification, some advanced checks, and anomaly detections, and also filters and handlers.
The first option here is log classification. Instead of manually checking logs, we can build we can train a model, machine learning model, to work for us. But the data centers can vary a lot from one cloud to another, and pre-trained model can be not enough for your specific situation to provide accurate predictions. And the next step here is to make a fine-tunable model that can be easily fine-tuned on your data in your circumstances. And different approaches can be used for making this kind of model, but the one promising approach is to pay more attention to text vectorization to get more accurate representation of your data. It means you can use a more simpler classifier on top of that to make it easily adjustable to your new data.
Okay.
And as the machine learning can be used like a variety of methods, like simplest bag-of-words based classifiers to large language models. It all depends of amount of collected and labeled data and cost of training model and research in that area.
Okay, so another source of information about our system are metrics. There are a variety of metrics that are generated by OpenStack systems, and those metrics actually can be used to create some domain-specific checks by an operator and actually make some forecasts based on data, and we can use those forecasts and actual data to use those in combination. Those can be used as indicators to anomalies. Well, yeah, basically.
And the next direction of in building monitoring systems is promising direction is root cause analysis. This approach can be used as part of message filtering system. It's not a secret if some part of the cloud, some host or service falls down. It produces not only one meaningful notification, but a lot of side notifications as a consequences of that one. So in order to get more information from that, we have to know what is the root. We have to build algorithms to find the root cause. We cannot just filter them on, because in next time it can be some of them can be root cause of some incident.
Well, so basically, root cause analysis allows us to reduce the load on operators' attention. Well, imagine the operator that receives thousands of notifications with different meaning, so it's easy to get confused actually. So by applying this approach, we can provide only necessary and, well, let's say, accurate notifications, and so that the main trouble can be solved in order to get system in a proper state. Well,
and in conclusion, the combination of machine learning and algorithms in enhancing OpenStack is not just a technological advancement, it's a strategic advantage. As we explore data-driven decisions, dynamic workload management, and power efficiency, we're shaping future where performance, cost effectiveness, and reliability come together.
Well, utilizing these advancements actually helps us elevate OpenStack efficiency on new heights and bring us to the future where each computation is powerful and brilliantly optimized. Basically, this picture just to recall the name of the company. Basically, your workload is well packed as all those fishes in a can.
And in a perfect order.
Yeah, basically that's it.
Thank you for your attention.
And that, ladies and gentlemen, is why our customers love FishOS. Is that right? This is the sort of benefits they get. I love the metaphor of the fish packed tightly in the can. That's what we call that. There was actually one question that came up. What happens when a virtual machine with a workload crashes? Is the data lost? Is the operational data lost, or can it be recovered?
Okay, well, actually it depends on the particular system, but generally it's, well, the better practice is to use cloud storage to save any important data, since, well, if all the necessary data is constantly being saved, then it's not a big deal, but actually all the operational data can be lost, of course. It happens every time when you run a computer. If it crashes, then you're lost what you've done, if you have not saved it before. So basically, basically the test, but a virtual machine can be easily migrated or evacuated upon the start of that host that crashed. But, well, actually there are some ways to reduce the consequences, bad consequences from.
And we can discuss it during the lunch.
Yes. So, thanks.
Come and discuss it with them over lunch. So thank you very much to our great pair of speakers, Dr. Vadim Vildanov and Ilya Butorov. Big round of applause.